Hello everyone. So today we are going to understand builder design pattern. This is also one of the most used design pattern in the industry. So what is the builder design pattern? So it is a creational design pattern that helps construct a complex object step by step and separating the construction logic from the final representation. So till now we have seen few of the design patterns which belong to behavioral type, and this is one of the design pattern which is a creational design pattern, and it is like we are focusing on creation of the complex object in a step-by-step manner. So let's see, like without using builder pattern, what issues or what the problems we used to face and why this pattern came into existence. So here I let's see this example through a code to have a better understanding. So let's say if we want to create or construct a query. So query is nothing but the select statement, select star from the table name, and if the conditions are required, then in the where clause we'll define the conditions. And if we need to have the final output ordered in format of ascending or descending format, we will define that in the order by clause. And if any other conditions which we need to apply, we will use the respective SQL clauses to implement that. So here, let's say user has a requirement that they need to just have a query, like they need to just have simple query, which is like select star from the select star, or let's say selects from the columns and from that particular table. So in future, let's say there is some new requirements coming into our application where there needs to be some filtering from like whatever the set is getting returned from select star from that table name. We want to filter based on some of the criteria. So we need some where clause conditions to filter on top of that. And let's say in future we got some more requirement that we want to even order the output result, the output set which is getting uh, execute like whenever a query is getting executed and whatever the output is getting returned, that needs to be ordered based on one of the column in the ascending or the descending format. So in that condition, we need to again have the order by clause into our query. So let's say if we were building a query without using the builder pattern, how would this look like? So let's say uh, we have defined a class. It has all of these attributes, which is the table, which is nothing but the table name. The columns are nothing but the columns which are used in the select clause. Conditions are nothing but the where clause conditions. Order by ascending or descending is what defined by this attribute. And the order by on which column we want to order by is given in this order by uh, basically the attribute, and the limit is nothing but we want to limit how many output rows we want in the final output set, so that is controlled by this limit attribute. Now, as I explained, few of the scenarios where we just need only select star from the table name, and in future we need some where clause conditions like filtering on some columns, and even when in future we have some requirement where we need the output getting ordered by some of the column, being it ascending or descending, we need to have the order by clause also in place. So now, let's say in the name table is something which is the mandatory attribute that we need while considering the query. Otherwise, that makes no sense. So for that, let's say we define one constructor for this class with one parameter, which is a table, right? In future, we want some specific columns. Instead of star, we need some specific columns need to be selected from that table. So we went ahead by creating a new constructor with two parameters, which takes one parameter as a table name, and the second parameter as a list of string, basically the columns which we want to use to the select clause. Similarly, let's say in future we have some filtering based on some conditions, like on particular column, we need to have that conditions getting applied in the where clause. So we created one more constructor with three parameters, one being the table name, second being the columns which you want to select in the select clause, and the conditions which will be present in the where clause, right? Similarly, let's say in future we have a requirement of having all of that, like we want to limit the output of a result, we want filtering on some conditions, we want to order by the output result which is getting returned. So we went ahead and created one more constructor with all of this requirement. So this is something which is not a good design. So whenever there's new requirement coming up, we are going ahead and creating a new constructors with different arguments getting passed in that constructor when constructor is getting called, right? So like this is something which does not hold our design principles as well, so that our code is not all following the open close principle. Or also, let's say, uh, like this pattern, like creating this multiple constructor is also known as a telescoping pattern, where we go on creating new constructor based on our requirements, right? So to overcome this way of writing it, we have builder pattern, which helps us creating the object, which is the complex object, by a step-by-step method, in a step-by-step manner. So, what all problems could be there in this type of way of writing or creating the objects is like this. Let's say here, all of these parameters are not mandatory for all of the users, right? Some users does not require any filtering on these conditions. Some users do not require any output getting like sorted based on the ascending or descending order on some specific column, or they don't want to limit the results which are getting outputted. They want the entire result of that query, right? So in that scenario, we need to pass null here, right? We need to we won't be passing any conditions or any of the values here, or else we need to define that specific constructor for that user's requirement, right? These are the two ways. So this code becomes very difficult to maintain, and it's not easy to extend as well. It is difficult to test, like whenever a new requirement comes into our application, we need to test all of the other use cases which were present previously as well. Even while calling the constructor, like whenever a client is calling the constructor uh, to run this, they need to make sure that the ordering is maintained. They can't pass in the values out of order. As you can see here, I've taken these three conditions. I mean, three type of variants of calling that constructor. And let's say we have swapped this list, like the conditions and the columns which we want in the select clause get swapped, then that makes no sense while creating the query. So we need to also make sure that the ordering in which these parameters are getting passed when client is calling this is in the correct format. So like this type of coding style is definitely a bug prone, right? We can easily get into situations where we might run into some of the errors or unexpected results. So hence to overcome this, we have gone ahead implementing the builder pattern. So before seeing that how the builder pattern is implemented for the same example, first let's run this in our terminal and see how the outputs are getting generated for different sequels, and like what when should the builder pattern be used. We'll look into that first and we'll then jump into the implementation part. So this is calling this constructor, basically the first default this constructor with one argument, and this one is like calling for table name for the select clause, and it wants to order by basically, and which format, like ascending, descending, and the limit. So it is calling basically this constructor, this one, 42. And the last one is like it is calling the last constructor, like where we want every of the parameters getting passed, this one. And hence once like whenever we are running it and we are printing like how SQL will get generated, is something like this. First, for the first SQL query, this is something which is getting generated. The second is like select name and email from the users table. Users is nothing but the table name, and we are ordering by the name and in the ascending format. I think by default it's ascending. So if you want to define for descending, we explicitly have to give in the SQL. But for ascending, you don't need to explicitly define. And we are limiting. And the third one is the output where we want to filter based on the age, and we want to final like output should be returned in the ascending format. And we want to limit the result by just returning the 10 rows from the whatever the set it got generated, right? So this is how this approach is getting implemented. Now let's see when to use the builder pattern and what are its benefits of using it. So I already discussed the problems which we have faced without using this builder pattern. So it is like difficult to read and write, error prone, even difficult to test, difficult to maintain. It's not easy to extend. These all possibilities or the problems we have with uh, this implementation, the naive implementation. Now let's see when to use this builder pattern. So an object, if an object is having many optional fields. So here also you are saying that all of the fields parameters were not mandatory, right? The arguments which we are passing. So based on the requirements, the the fields can become an optional or the mandatory field for the user or the client. So in that scenario, this pattern is like we should use this pattern. And if you want to avoid the telescoping constructor or the long parameter list, as we have seen in the code that we defined every different constructor with different arguments. So if you want to avoid that, we should go ahead with builder pattern. And also like object creation takes place in multiple steps, right? It's like, and possibly in the specific order we want to create an object, we go ahead by using this pattern. Now let's see where is this pattern used mostly. An example like in the object relational models, ORMs, and the query frameworks, builder pattern is used, like widely used to construct the complex queries, right? Now let's see in the code as well, the same. Firstly, we'll create the class query. This remains the same. We'll also have the list of attributes for this class. This also remains the same. Like only changes like whenever we'll be creating the, whenever we'll be when in the constructor, whenever this attributes will get initialized, at that point of time we'll pass an object of type builder. Okay, so this is nothing but the builder pattern where we have built this object, and this builder will initialize this basically the attributes of this class. So this builder is an object of type builder. So here we go ahead and create a static class builder in the same class query class itself. And we are making it static because we don't want its object to get created while calling any of these functions present inside it. So here also we'll have the same list of list of attributes which we have in the original class, meaning this one, right? This remains the same. All of these attributes here and present here remains the same. And as the table is the mandatory attribute, we have like whenever we are calling the constructor of this class, we are passing that mandatory uh, parameter here. So we make sure that whatever the mandatory parameters are there inside our like object creation part, we try to pass it in the constructor of the builder itself, right? And whatever the optional parameters we have, we create individual functions for those. So here, for let's say the columns, right? We will have the list of columns. So this way of passing is nothing but in Java. When you do this string dot dot dot, it allows you to pass multiple strings, multiple meaning. Whenever I'll show you when we will be calling it from main. How is this function getting called? But we want to pass multiple arguments of type string. You can use this type of format, and we are adding those columns inside this list, whatever is getting passed here. Okay, where is nothing for the conditions, same way. here as well. So we'll be populating the condition, and the order by here will be specifying which column we want on, like on which column we want to perform the order by, and in which direction is nothing but ascending or descending. And the limit is nothing but whenever the final output is getting generated, how many rows you want to see in the final output console, right? That is nothing but limit. So if you see here, every time we are returning an object of type builder. Whenever we are calling any of these functions, we are returning an object of type builder, right? So how will this be helpful is like assuming, so understand it in this way. And at the end also we will have the build method which we'll be calling here inside this builder class itself, and which will return an instance of the query which we are creating, right? The query object, the main class object which we are creating. So understand it in this way. How will this work is, so let's say whenever an object, like whenever we will be calling this class, like whenever create an object of this class, let's say query1 equals to new query. Okay. And we have defined this builder class itself as a static class inside this class itself, right? So dot, whenever you will call dot builder, you will be able to call this one, this constructor, right? So dot builder, what it will make sure is whenever you will call new query dot builder, so what will happen is like it will call the constructor of this builder class, and you will pass the required parameter, which is the table name there. And as it is a constructor is getting called, whenever we call a constructor of any class, it returns an instance of that particular object of that class. So that gets returned, right? So now new query dot builder with the argument is holding, that is nothing but the returned instance of type builder itself, right? Now dot select, if after that you do dot select with the columns dot where, so each and every call is returning again a object of that same type, right? And whenever you will call at the end dot build method, that will, what it will do is, as till now we have got an object of type builder whenever we were calling any of this functions. And when you call at the end dot build, like when you have done by building, passing the optional parameters and the required parameters into your query construction part, object creation construction part, you call this dot build, right? When you call dot build, it returns an query instance, which is like the instance of the query class which we want, right? And here we are passing this. This is nothing but an instance of builder which is getting passed, which got created till now, right? So when this gets, like whenever we will be calling this new query, this basically calls this constructor, and it initializes by whatever this builder instance is holding, whatever we constructed. It initializes each of these attributes of this class, right? Of this query class by whatever is with whatever got constructed in the builder, and hence that final object gets returned, right? And this is nothing but the sequel to print how it looks when the finally we got the when we are creating. And let's see in the main how it is working. So when I already explained this, like whenever you call dot builder, so this is nothing but calling the constructor of that builder class with the parameter, the required parameter. Here we only have one required parameter, which is the table name. So this instance is nothing but this, whatever this is, it will be the instance of builder, right? So dot select, like whenever you have an instance of a builder itself getting returned, you can call dot select. Why dot select directly? Because it's a static class. And whatever at the end till here, it will return the builder's instance, right? Because every function call is returning an instance of its type itself. If you see here, we're returning this, so it is returning an builder instance itself. And whenever you call this build, so builder dot build is nothing but this will be called, right? And its responsibility is to return the final query instance. So here we'll return new query, and this is nothing but the builder which got constructed till now, which will be used here to initialize all of these attributes, right? Presented here in this constructor. And we'll get the final query instance of type query, and we'll just see how the SQL look like. So basically, it should be select name and email from users where age is greater than 18 and active is equals to true, like users activity is equals to true, and it's order by name and order by direction is ascending, and we want to limit it by 10. So let's see in the terminal how it looks like. Okay. So as expected, select name and email from users where age is greater than 18 and active equals to true, and order by name equals to ascending, like name is ordering by direction is ascending, you want to limit it by 10. Also, what flexibility here we get is we don't have to care about the ordering of calling these functions. Like we can call the where a function first before the select as well. Still, it will return the same query, like same expected payoff from the SQL would be returned. So let's see that as well. The same output gets returned, like it is the same format, right? I mean, even if you use the select function after the where function, that doesn't matter. So it becomes easier. You don't have to remember the function, I mean, where the position of the exact arguments needs to be there. The only responsibility is like whatever you require, you call it, because we provide each and every functionality in the builder class, and in whatever order you want to call, that doesn't matter, right? So now let's see the key takeaways of this pattern. So the key takeaways are like no telescoping constructor or the null arguments issues will be facing. You don't have to write multiple constructors for each and every requirements we have. It will be definitely easy to extend. So in future, let's say you have some more conditions or some more functionality you want to add while constructing a query, you have to just go in the builder class, add that function, and you're just done. And it's flexible ordering, which I showed right now, that your ordering does not matter. You can call functions. The only thing is like you have to just call the function as per the requirement, and you're done. You don't have to worry about the order. So yeah, that's it for this pattern. I hope you like the content. If you like the content, do like, share, and subscribe, and follow for more. Till then, bye bye. Take care and have a nice day.